The British Army is taking a significant step forward in modern warfare with its Land Autonomous Collaborative Platform, LACP, program, which seeks to integrate autonomous drone systems alongside its AH-64E Apache attack helicopter fleet. A dedicated workshop scheduled under the LACP initiative will explore the potential development of next-generation unmanned aerial platforms capable of operating in tandem with manned helicopters. This ambitious project aims not only to enhance battlefield capabilities but also to ensure that the British Army remains agile and adaptable in high-intensity combat scenarios. Pairing the AH-64E Apache with autonomous drones promises to combine overwhelming firepower with advanced intelligence, surveillance, reconnaissance, ISR, electronic warfare, and precision strike capabilities. The resulting synergy is designed to extend operational reach, increase survivability, and allow forces to operate more effectively in complex and contested environments. The autonomous drones will follow a commanded, not controlled, approach, meaning they will be able to execute complex missions with minimal human intervention. This philosophy allows drones to conduct reconnaissance, identify and acquire targets, engage in strike operations, and perform electronic warfare activities while simultaneously deploying supportive effects to increase the survivability of manned helicopters. By offloading these critical tasks from Apache pilots, the Army aims to reduce the cognitive load on aircrew, simplify operational logistics, and enhance both effectiveness and mission endurance. From a technical perspective, the AH-64E Apache remains one of the most sophisticated attack helicopters currently in service. Powered by upgraded T-700 GE-701D engines and equipped with advanced composite rotor blades, it offers improved lift, maneuverability, and overall agility. Its suite of onboard systems includes the Longbow fire control radar, modernized target acquisition sensors, and secure data links for real-time battlefield connectivity. The LACP drones are envisioned to complement these capabilities with vertical takeoff and landing, VTOL, performance, payload capacities exceeding 200 kilograms, and a modular design that supports various mission packages, including surveillance pods, precision-guided munitions, and electronic warfare systems. Together, this manned-unmanned ecosystem acts as a force multiplier, significantly extending the reach and lethality of British Army aviation units. Operationally, integrating autonomous drones with the Apache E-fleet provides distinct tactical advantages. Drones can safely penetrate high-risk zones to identify threats, carry out suppression operations, or disrupt enemy air defense networks, while Apaches engage from standoff positions. This reduces exposure of manned platforms to hostile fire and enhances the overall survivability of helicopter crews. Moreover, constant surveillance and rapid precision strikes maintain pressure on adversaries, shortening the sensor-to-shooter cycle and allowing the Army to process intelligence and neutralize targets faster than potential opponents. The LACP program also reflects broader strategic imperatives facing the United Kingdom. Rising global instability, demonstrated by the war in Ukraine, increased Chinese assertiveness in the Indo-Pacific, and the proliferation of low-cost drone technologies across modern conflict zones, has forced NATO members to reassess their defense priorities. By investing in manned-unmanned teaming, the British Army strengthens NATO's collective deterrence posture while signaling its commitment to modernizing force structure for the demands of multi-domain operations. The program underscores the UK's recognition that future conflicts will demand rapid decision-making, integrated battlefield awareness, and technologically advanced force multipliers to maintain operational superiority. To facilitate collaboration and accelerate innovation, the UK Ministry of Defence has scheduled workshops on August 21, 2025, at the Defence Battle Lab in Dorset. These sessions will bring together critical stakeholders, including the Defense Science and Technology Laboratory, DSTL, the Defense and Security Accelerator, DASA, Futures Lab, and leading defense industry partners. The workshops aim to foster innovation, identify technical solutions, and ensure seamless integration of autonomous platforms with existing manned systems. This development comes in the wake of the British Army's full operational introduction of 50 AH-64E Apache helicopters, delivered by Boeing earlier this year. Stationed at Wadisham Flying Station and Middle Wallop, these aircraft represent a significant leap over the retired Mk-1 variants, featuring upgraded engines, advanced sensors, and expanded firepower. Each helicopter carries up to 76 Hydra 70mm rockets, 16 Hellfire missiles, and a 30mm M230 chain gun with 1,200 rounds, providing formidable striking power for European air-land operations. By integrating autonomous drones with the enhanced Apache fleet, the British Army positions itself at the forefront of manned-unmanned teaming. This development is not just about boosting firepower, it's about reshaping the operational approach to modern warfare. Autonomous drones extend the operational envelope of manned helicopters, performing high-risk missions that were previously too dangerous for crews. They enable persistent ISR, electronic attack, and precision strike capabilities while freeing human pilots to focus on critical tactical decisions. This layered approach ensures greater flexibility, faster response times, and resilience against sophisticated, near-peer adversaries. The strategic benefits of LACP extend beyond battlefield efficiency. By leveraging unmanned systems alongside manned platforms, the British Army can maintain operational tempo in protracted conflicts, reduce attrition rates among pilots, and achieve cost efficiencies over the long term. The autonomous platforms also provide scalable solutions adaptable to different mission types, from urban warfare to open field operations, making them versatile assets in multi-domain engagements. Moreover, this initiative sends a clear message to both allies and potential adversaries. For NATO, it demonstrates the UK's commitment to advancing collective defence capabilities through innovation and technological investment. For adversaries, it signals that the British Army is actively preparing to counter sophisticated threats with integrated manned-unmanned systems, capable of conducting rapid, precise, and resilient operations in contested environments. Looking ahead, the success of the LACP program will likely influence broader defense procurement and operational strategies. As autonomous technologies mature, future iterations could include swarming drones, enhanced AI-driven decision-making, and improved interoperability across air, land, and sea domains. The program serves as a blueprint for next-generation combat operations, where human pilots and intelligent machines collaborate seamlessly to achieve mission objectives while minimizing risk. In conclusion, the British Army's integration of autonomous drones with the AH-64E Apache fleet represents a landmark evolution in modern military capability. Through the LACP program, the Army is not merely acquiring new hardware, it is transforming the operational doctrine of its aviation units. By combining advanced manned platforms with intelligent, semi-autonomous drones, the British Army enhances its combat effectiveness, operational resilience, and strategic flexibility. As global security challenges evolve, this manned-unmanned teaming initiative ensures the UK remains at the cutting edge of military innovation, capable of responding rapidly, decisively, and effectively to threats in increasingly contested environments.